Hi, I'm Iwao Hatanaka. I'm from the IBM Watson Platform Services team. And today I'll be talking about the Watson Developer Cloud. We'll be doing a deep dive. This is the March Madness edition of the talk, so I'm going to start it out with a question to the audience. How are these two alike? We have Martin Fowler, the chief scientist from ThoughtWorks. He gave the keynote speech this morning on agile architecture. Brilliant speaker. And then we have Slash, the lead guitarist for Guns N' Roses. Any takers? The color of the beard matches his hair. Yeah, that's correct. Let's see if we can find another similarity. So there's this app out there called Your Celebrity Match. And we can enter in Martin Fowler's Twitter ID. And we find that based on the personality traits that came back from one of our Watson services, Personality Insights, that various personality traits, like they're both curious, they're somewhat easygoing, they're outgoing, sensitive, and compassionate, Martin actually lines up with Slash, among other celebrities. So you can see there's other similarities here for celebrities and differences. The way this works is that, the way the app works is that we take the last 2,000 tweets from Martin Fowler, and then we feed that as input into our Watson Personality Insights service. It creates a personality profile, and then we take that profile and we compare it to the other profiles of over 230 celebrities in this database. And then we come up with this answer. So if you see Martin Fowler in the hallway, you can tell him that he has the personality of Slash, and you have the data to back it up. So this is just an example of an application that you can build with some of our services. Yes?
Could there be a Watson-based
dating service? You can build one with the services. All right, yeah. Let's do that. Okay, so as far as the agenda, I'm going to go over the Watson Developer Cloud, give an overview of that, go into the platform architecture, take an inside look on what we do to get a service on board onto the platform, and then go into some detail on the services. So the Watson Developer Cloud, it's a set of REST APIs and SDKs that utilize cognitive computing to solve all kinds of problems. How many in the audience have already started using the Watson services? None. Oh, one. Okay, good. Well, we'll get more of you on board. It's really straightforward as far as building apps on top of it, and you'll see. So in the spirit of March Madness, here's our fantastic 14. It will get to Sweet 16 soon. You'll note that some of them are indicated with new, so those have been released in the past 2 months. Most of them are in beta. The one far left, the Personality Insights, which I showed a demo of, that is GA. Okay, so we saw what Personality Insights can do. Concept Insights allows you to explore content in more advanced ways than traditional search or keyword matching. It builds a concept graph and then identifies conceptual associations within the content, both explicitly and implicitly. So for example, if I gave the service the term natural disaster, what it would come back with would be documents that contain the word natural disaster, but also documents that talk about hurricanes or earthquakes or typhoons without the words natural disaster in that content. Concept expansion maps colloquialisms or euphemisms into more understandable phrases. For example, Big Apple would map to New York, New York City. Titletown would map to Boston with all the sports championships and record snowfall. Language identification detects the language in which the text is written in. Machine translation, language identification, we support 25 languages today. Machine translation translates from one language to another. We support 5 different languages there. Message resonance analyzes content and scores how well it will be received by a specific target audience. And we'll go into some of these demos later on. Question and answer. This is the granddaddy of the Watson services. It's the engine that enabled Watson to win in Jeopardy back in 2011. So it interprets and answers questions based on a body of data or corpus. Currently on the services, the corpora that we support are healthcare and travel, and we'll increase the number of corpora out there, and at some point you'll be able to build your own. So the service returns answers to questions with confidence levels as well as supporting evidence for those answers. Relationship extraction takes unstructured text and extracts entities such as people, locations, and also identifies relationships among those entities. Person is employed by organization. Person resides in location. Speech to text, text to speech, that's pretty self-explanatory. Trade-off analytics is a service that helps people optimize their decisions while balancing multiple, often conflicting goals. And the service also provides a widget where you can visualize some of those trade-offs and recommendations. Visual recognition analyzes images and identifies them based on machine learning models. And then visualization rendering provides graphical representations of data analysis for easier understanding of that data. And then lastly, we have Alchemy API, which provides a set of advanced text mining and computer vision APIs that complement the suite that we have here. IBM just acquired this company earlier this month, so we're still folding them in. Okay. So we created the Watson Developer Cloud to make the core technologies available for developers to build apps upon. The vision is to have thousands of cognitive apps bloom and flourish. And right now we have over 5,000 developers developing Bluemix apps with the services. And we want to continually increase that. Okay, with the Watson services, we're taking a different approach to getting developers on the cloud. The old way was that developers had to wait for a GA release. It often was restricted to partners. But the new way is, with these services, we've got open beta releases. It's open to anyone in the world that has a Bluemix account. And we've been participating in numerous hackathons to get students to use our services and give us feedback, because we want to continually improve the services. So this is not your father's IBM anymore. Case in point, I've got a company-issued Apple MacBook Pro here too, so definitely not your father's IBM. As far as Bluemix, as Mike Vanderwerl talked about this morning, it's a platform as a service. The key points of the architecture here are that you can easily build a mobile app or a web app over the internet. What's going on is Bluemix creates VMs on top of SoftLayer, and you can build your apps there and bind to the services within their framework. I can show you what Bluemix has as far as their dashboard. So you can go onto the Bluemix dashboard and you have available starter kits, boilerplates that come packaged with a particular runtime and a service. Here's one for Personality Insights with Java or with Node.js. Or I can choose to pick a runtime in my favorite language, whether it be Java, Node.js, Go, PHP, Python. And then I can bind a service, one of the Watson services, to an app that runs on one of these runtimes. It also provides a dashboard where I can see the ones that I've deployed, for example, concept expansion on Java with the service bound there. So a very quick way to get started with a Watson app is to go to our GitHub repository. Actually, so we have on Watson Developer Cloud GitHub a set of starter kits that you can choose what specific service and the language type. I can pick Personality Insights on Node.js. Again, this source code is for the sample application. And there's instructions here on how to leverage some of the Cloud Foundry command line interfaces, but there's a magic deploy to Bluemix button that will, underneath the covers, leverage Bluemix DevOps services. And what it does is it creates a project and clones the repository, builds it, and then pushes the app out to Bluemix, and it's up and running. In the interest of time, I'll just go over one that I've already deployed here. So here's an example of the Personality Insights in Node.js. And I'm able to edit the code within the browser. Right, so I can come in here and start typing Watson dot, and it even does code completion in the browser. So I can edit it, make my changes, and then build and deploy it. Last time I did this was the Node.js version that was pushed. The sample app with Personality Insights, it takes a text from Moby Dick and then analyzes it. You can cut and paste whatever text you want in there, and you see how fast it does a personality analysis as well as gives you a visualization of the results and the scores. Okay. So we talked about the deploy button, and then there's a lot of great documentation for each of the services, how to get started, some of the details around them, the sample apps, and then some Swagger documentation, developer's best friend. So for each of the services, we have in-depth Swagger documentation for the REST APIs. It shows you exactly what the inputs and the outputs are. Okay. Okay. The platform architecture. So about a year ago, we started to look at how we can get the Watson services on the cloud. And we set particular goals as far as the architecture is concerned. We wanted to deliver an open platform to host the services and provide operational excellence. So we wanted to enable services to be cloud native. We wanted them to be highly available, auto-recoverable. We wanted to embrace microservices, loosely coupled services in an SOA environment. Be able to continuously deliver updates and upgrades. Be elastic as far as being able to increase or decrease the number of instances based on load. Get visibility into the operations on the metrics, be compliant with security. And last but not least, be able to onboard services into our environment in a painless manner. Have them use common components, tools, and follow a process that helps them quickly get their services up and running. So what we did was we leveraged the Netflix open source stack. And that enabled us to get over a dozen services in less than a year up and running on Bluemix and SoftLayer. So thank you to Adrian Cockcroft, who gave a speech this morning. He was the former chief architect at Netflix. And then thank you to Andrew Spiker, former IBMer who defected to Netflix, who first ported the Netflix components to SoftLayer to get us running there. So from a logical view, the platform involves SoftLayer at the bottom as our infrastructure as a service layer for image management, cloud and storage provisioning, whether it be bare metal or VMs. And then on top of that is our cloud services fabric with components for DevOps, service registry, centralized logging, operational visibility, things that I mentioned. And then on top of the fabric is a layer for services to leverage platform libraries for metrics or health checks, as well as adhere to various platform design patterns, whether it be microservice or other. And I'll get into some of those. So rather than build everything from scratch, what we did was we built a best-of-breed platform. We took the components from Netflix that we felt would do the job for DevOps with Asgard or dynamic routing with Zool. I know, funky names, but those are from Netflix. Design patterns like the historic circuit breaker. So that philosophy is fail fast, recover rapidly. And so with the interfaces and abstract classes there, you don't keep cascading failures. You nip it in the bud and recover quickly. Metrics, servo library, et cetera. So Netflix plus, we built our own components. For example, for the image bakery, we built a component called Imaginator, which essentially builds images to deploy to SoftLayer. We also forked versions of Asgard and Zool to enhance them to do what we needed them to do. And then we brought in other open source components such as Elasticsearch Logstash Kibana for centralized logging and Grafana for platform dashboarding to view the metrics. Okay, so I'll go into a little bit about some of these components. Imaginator, our philosophy is that every change should be done via images. We do not SSH onto the various nodes and change the config and tweak them. If we're going to make a change, we're going to spin up a new image and deploy that image. The platform provides base images to the service teams, so it's based on Ubuntu 14.04 with some hardening for security, with some agents for logging and metrics. If you need a servlet container, we put on Tomcat. If you're a non-Java service, then we have what we call Sidecar, which allows you to fit into the framework for non-Java services. And then, so the service teams build their image on top of these base images and sits in an Imaginator component. Of course, there's a Dream file that describes the dependencies and the build targets. And we're using Gradle underneath the covers to create the Debian packages. So you can see in the diagram, the base image with the service implementation in a Debian package fed into Imaginator gives you a CCI, an image that can be deployed to SoftLayer. And it's deployed through Asgard. So Asgard allows us to, with a few clicks, deploy that image into a runtime environment in what we call an auto-scaling group. So I can, for a group for that particular image, I can say I want a minimum of 2 instances, a maximum of 6 instances, with starting out at 2, for example. Also, the console allows us to perform canary and red-black testing, or deployments. So canary testing is that I can deploy a specific version and have it run side by side with, for example, an existing version in production. Whereas red-black deployments is how we actually push new versions of the services. For example, if I have version 1 running in production, it's red, and then I have a version 2 that I want to push to production. I run it side by side, so they're red, and a load balancer is feeding traffic to both auto-scaling groups. And once I'm happy with the performance, then I can make the old version, version 1, black, not take it down, but put it in an out-of-service state. Then I test with the version 2 to ensure that it's good to go. If something goes wrong, then I can still revert back or roll back to version 1 because I haven't taken it down yet. If everything's good, then version 2 is live, and then I can, at some point, take down version 1. And then various auto-scaling policies for HA and instance recovery with Asgard. Okay, Eureka is the service discovery component and allows us to locate services mainly for failover and load balancing. The idea here is that the service images have clients in there so that they can register themselves to Eureka, and then also agents to discover other services. So if I want service A to talk to service B, then it will go through Eureka, and it uses what we call a VIP name. It doesn't look it up via host name or IP address. It has a VIP name, and then Eureka will return back the healthy set of IP addresses for that VIP name. And then you can use a client like Ribbon, it's another Eureka, Netflix component that will then load balance out to the healthy nodes. Archaeus is a dynamic config management component, allows us to do property overrides based on environment or state. The key thing here is for dynamic properties, we leverage Apache Zookeeper as the high-speed distributed data store. Zool. Some of you may know Zool as the demon that was in Sigourney Weaver in the movie Ghostbusters, but for us, it's just an edge service that dynamically routes requests through filtering. So we have pre-routing filters, routing filters, and post-routing filters. And those are actually written in Groovy so that we can make changes and dynamically push them if required. Again, it leverages Eureka to know which nodes to route to. Centralized logging. This is an open source stack that we brought in for Elasticsearch, Logstash, and Kibana, along with Kafka, which is a message broker. So you can see down here, again, with the base image, it already comes with a Logstash shipper agent so that logs can be published to a Kafka queue. And then the Logstash component pulls the messages from this reliable queue and then persists them into Elasticsearch, and then we can do searches from a Kibana dashboard. So the idea is that you don't have to SSH into every single node and find the appropriate log file. You can go onto Kibana and do your searches, and it will pull in the appropriate log information. Operational visibility, again, here we pulled in other open source components such as Graphite and Grafana. The design philosophy here is that we want to see the metrics within 10 seconds of publishing. So with the picture here, again, with the base image, you get agents that publish metrics to the Graphite data store. In some instances, you can instrument your code to send various key performance indicators, but there's other system level metrics like CPU load, et cetera, that get automatically sent once you're built on this base image. So it's stored in Graphite, our time series database, and then Grafana is our dashboarding component to view them. Same with the Hystrix dashboard. I mentioned the circuit breaker pattern, so we can view the health of circuit breakers to see if they're open or closed. And also with uptime, we can monitor the health of the various nodes as well. These tie into PagerDuty so that if certain thresholds or conditions are tripped, that we do get PagerDuty alerts to then do some diagnosis. Siren is the component that actually takes metrics data from Graphite, and then you can trigger based on certain metrics from Graphite, but then also PagerDuty is tied to uptime, to Hystrix, et cetera. This gives you a flavor for what Grafana can give you as far as dashboarding for your CPU read-writes on the internet, Ethernet interface. And then at the Hystrix dashboard to give you a bird's eye view of the health of the circuits and the throughput of the transactions going through the services. Okay. And then for infrastructure test automation, Netflix has the Simian Army. Now, we've only deployed the Chaos Monkey here. And the Chaos Monkey essentially goes off and deliberately kills instances, mainly so that you can expose weaknesses and fix those weaknesses and bolster your auto-recovery mechanisms. Netflix likes to do this during the day in production, but we're not there yet. And then the other simians here are still caged for us. Latency Monkey, for example, you can simulate service degradation. Conformity Monkey will shut down instances that don't follow best practices. 1018 Monkey, localization, internationalization Monkey, will test with different languages and character sets. And then there's the Chaos Gorilla, the big one that can take down a data center or a pod to test out your multi-data center failover. But we're not there yet on that one either. Okay, so how do we onboard a service onto the Watson Developer Cloud? Again, we want to make it as easy as possible for service teams to get onto our cloud and have their services available for everyone to use. We first assess what the various characteristics of the services, what type of interfaces they have, whether stateful, stateless, what kind of persistence strategy they have, concurrency requirements, and then start to build out a migration plan to get them onto the CSF. Some of them map fairly straightforward, but some of them are your monolithic services that we have to start to decompose and get them eventually to a cloud-native state. In those cases, it's not a big bang. We don't want to just try to get them on in a big bang approach. We get them there in what we call a hybrid approach. So start to migrate some of the components for that service so that eventually they'll get to cloud native. So for example, if they have a standalone DB2, we can migrate them to Cassandra as a service if they can go NoSQL. If they have to stay relational, then they can leverage a Bluemix DB2 instance, or get them off of a standalone ActiveMQ and get them to use our Kafka message broker, right? So then, the Kafka message broker is already built in with failover and resiliency. So I guess it's hard to see, but once the service is on our platform, they get to reap the benefits of dynamic routing from Zool, the service discovery from Eureka, all the monitoring and metering that's built in on the platform. They get to leverage the centralized logging from the ELK stack, and they get to deliver updates and upgrades through a continuous delivery process through Imaginator and Asgard. Okay, so I'm going to go into a little bit on each of the services that I touched on in the beginning of the talk. Personality insights we saw with the Martin Fowler and Slash comparison. Again, what it was doing here is analyzing the text with the big 5 personality traits in mind. It's openness, conscientiousness, extroversion, agreeableness, and N for neuroticism. But I think we call it emotional range in our docs. But in any case, it allows you to build an app that engages your users on their terms. So we saw the celebrity match. We actually saw the sample demo that's in there that Moby Dick was analyzed. Here's an interesting one from MSNBC that analyzed the State of the Union speech a couple months ago from Obama and compared it with all the speeches since 2001 when George W. took office. And so we can see here with respect to openness, there was a decline in openness from Bush to Obama with respect to the State of the Union speeches. Conscientiousness rose while they were both in office. Extroversion, decline in assertiveness here, right? And agreeableness, rise in most categories. And emotional range, or the neuroticism. So it looks like it increased while taking office, but then leveled off. And needs are just all across the board, whether you're Bush or Obama here. And then values, openness to change at a very high level. So interesting to compare Obama-Bush, State of the Unions, and obviously you can think of other applications that you can build to do analysis on the text and pull out the personality traits.